Welcome to our Mission V world on the topic of chemical bonding. Our resource begins in the house of prior knowledge, where the walls are covered in the course content students need to be familiar with to fully understand the concepts involved. As a team, we felt it was essential to highlight and clarify certain aspects of this and previous topics so that students did not progress into our world with misconceptions. That's why we decided that students must answer gateway questions before progressing. Question 1 asks, what is the smallest particle of an element that still retains the properties of that element? The answer is of course atom, which some students will already know. However, if students struggled with this, the information can be found on the walls of the house. The following 3 questions progress in a similar manner. Once these are answered, we can progress out of our house of prior knowledge. Next, we come to the periodic table, which is the cornerstone of chemistry. So as a group, we felt we needed to include it. The students name the table and proceed to a T-junction, which is split between ionic and covalent bonding.
First, we will proceed to the section on covalent bonding. Again, students are faced with a question before they can move on. This time, one essential to their understanding of covalent bonding. Upon entering, students are faced with a 3D representation of a covalent bond. In this section, we decided to include audio as we thought it was necessary to cater for the auditory learners as well as the visual learners.
Covalent bonding occurs when either atom has sufficient strength to completely remove the other atom's electron.
The audio is about 1 minute long and it explains the process of covalent bonding, which can also be seen in the models in front of them. On the model of the water molecule, the shared electrons glow. We feel it was important to emphasize these, as from our own teaching experiences, we know that this is a point of confusion. The new information the students have acquired is tested before they can proceed into the section on covalent properties. We have displayed the information in a clear and concise manner so that the important points of the section are stressed. Students can explore this area, but we will now teleport back to the T-junction.
Similar to covalent bonding, students must answer a relevant question in order to advance into the ionic section. Again, in this section, we will use audio and visual representations to clarify the topic.
Ionic bonding occurs between 2 atoms when one of the atoms has sufficient strength of attraction to remove an electron from the other atom.
We can see the sodium and chlorine atoms in their original forms and then ionically bonded to form sodium chloride by the transfer of an electron. Again, we will assess students' understanding of this section before continuing. From experience, we found that students have difficulty visualizing the ordered scale of a crystal lattice, so we felt that it was important to include a model that students can explore. The size difference between the sodium and chlorine ions are clearly shown in our structure. Similarly, we wanted to include visual representations of the other ionic properties. These are often misunderstood. First, we have a model of the ionic solid clearly showing the charge distribution. Our second model, then shows that ionic compounds have high melting points. This is due to the fact that large amounts of energy are needed to break up a crystal lattice. From our final model, we can see that sodium and chlorine have dissociated into ions in the presence of water. This does not happen with covalent compounds. The final property shown is that ionic compounds conduct electricity, which is investigated in the learning outcome OC44 found in the Junior Cert syllabus. This now concludes our tour of our resource on chemical bonding. We hope you liked it.